Germany, Vatican City, France, Belgium, Netherlands, Portugal, Austria, Syria, Hungary, Romania,
Hello, good afternoon, and welcome to you all. Can you hear me?
Yes, sir. Good afternoon, sir.
This is Zulfi from Mindshare. Yesterday, I sent you all the mail regarding that we are going to start our programming from today. initially we have planned 8 lectures, 4 for SPSS and 4 for R, as told to me by both the instructors. But I've got 5-6 mails that they are requesting that it will be better if we can continue with SPSS and complete the entire thing which we have planned rather than going jumping to the R initially. So we can create one more separate course for R for the next month, and in this we will for the next 4 lecture we will be having SPSS only. So I just want to know about your views, the participants present here. What do you, is it okay that we can continue with SPSS and complete the SPSS first?
Yes, sir. That's totally fine.
Yes, sir. I agree, sir, with that.
Okay. Okay. Kiran sir?
Good afternoon. Good afternoon, Jill,
Good
please.
afternoon. How are you?
Yeah, good, good, good.
So as requested by the students on email, and here also I have asked all the participants here. So I think the remaining SPSS part should be completed first, and then we'll go jump to the R. And we can create one more course separately for R and then for Python for the next month.
Okay,
So
okay, we'll make it. We'll make it. No problem for that.
continue the SPSS part. Thanks a lot.
Okay, okay, nice. Okay, we'll wait for some more time. There are only 35 participants so far. Okay, we'll be continuing with that.
Hello. Check. Sir, while waiting for others, can I ask a question either Julfi sir or Kiran sir?
Yes, yes. You can go ahead.
Good afternoon, sir.
Good afternoon. Good afternoon.
Sir, just wanted to know, since we're talking about postponing the R, and in relation to the SPSS and R, both, is it totally a different thing or it's very much correlated to SPSS, sir?
No, actually, R is completely different. Okay, what SPS? Yeah, what SPSS, it is a menu driven software. Okay, anyone can do. That is specially developed for social sciences. Okay, those who are not much knowledge of coding and all, and they don't need any theoretical base also. If they understand the concept, they'll be doing it in a simpler way. Okay, it is a menu driven one, but our programming is completely different. There we are utilizing the codes for each and everything, and there were some of the packages are there. So we will be doing much of the things with the packages. Okay, it is especially meant for statistics completely, but there were applications are there, different applications we do, like genetics, finance, forecasting, time series. Many things are there. For that, we have a bunch of packages. Okay, SPSS is meant for it's like a menu driven one. Those who are expertised in statistics, okay, for them only it is easily understandable. Okay. Any other doubt you have?
Good afternoon, sir. Can I ask a question?
Ah,
So basically, R and Python are syntax that are used in SPSS, right?
syntax? No, actually, here SPSS both the things are there. We can work on syntax based also or menu driven based also. Both we can work, but for you, okay, most of the statisticians they work for both. Okay, like a syntax based or menu driven based, but in R programming it is completely syntax based. Okay, this is not a menu driven one. If you know any of the package name, at least if you want to uh, compute descriptive statistics. Okay, so there is a function called summary. It will give you all the characteristics of a data. Okay, that we can do with the syntaxes, but here we are we are teaching about the steps. Okay, we are remembering how the menus are allocated for particular test, and we are explaining that only. Okay, but we are mostly focusing on how we how we easily make understand about the concepts of statistics with the SPSS. Okay.
Okay, thank you, sir.
Okay.
Thank you, sir.
Okay. Okay. So far only 37. Shall we start or wait for a few moments? 1 or 2 minutes and we'll start.
No problem, sir. We can
Okay.
wait.
Okay. Okay. Okay, we'll start now. I means instead of waiting one, time consumes. Okay, those who are not listening now, they can go through the recorded video after that. Okay, I need to present my screen. Okay, are you able to see this?
Yes, sir.
Okay, good. I am just going to here. I actually given a presentation to you on first day of beginning of this session. Okay, now I am covering a little things here. Okay, for today's session, and that is the descriptive statistics for grouped and ungrouped data, means a frequency data, and that means some count, minimum, maximum, range, okay, standard deviation, variance, variance, everything it will be covered. Skewness, Kartosis, okay, this and all I am going to cover with the examples. Okay, and categorical things I am not covering much, but we will be doing this also will come under this particular one. Okay, and when you are plotting box plot, okay, so you can able to get the 5 measure summary. Okay, that also useful for you. And other things I'm going to cover today is t-test. Okay, there are 3 tests for t-test that I'm going to cover when we are going for hypothesis testing, that we are specifically mentioning about uh, this small sample test, we actually call it as. Okay, and I'm covering little things on correlation and regression today. Okay, so basic things I'll cover. I'm not touching any theory, but whatever we are going to do the steps, okay, that you can keep remember, and I'll explain why we actually do the particular tool. Okay. So without time delay, I'll be going here for opening this one. Okay, frequency descriptive statistics for ungrouped data. Okay, I think you have the formulas for mean, median, mode. Anyone know, or maybe most of them? I think you have studied in your maybe in your +2 level also it is there. Okay, so maybe if you start with any research, then you are learning it with a research methodology. Okay, so those who don't know, just to go through the theory why actually we give these things, and most of them I think I assume that most of them from research background. Okay, so if not, you can give me. I'll go more detail in explaining. Okay. Uh, so here what I have done is, this is descriptive statistics for ungrouped data, means it is not ungrouped here. Okay, the completely I have taken 40 observations. That is, these 40 observations are the lengths of 40 laurel leaves. Okay, some of the leaves we are actually recorded. Okay, some it is a problem of the things we recorded here. Okay, so the lengths, okay, those who do plant science researchers, they do these particular things. Okay, identifying the species and finding out their length and width. Okay, so head circumference, everything they will be covering with that. And the variable x here, it is length of 40 laurel leaves. Okay, so that I have
Sir,
taken here.
please share the screen.
The screen is not visible.
Actually, we can see the total list of files, but I guess the window is changed now.
Okay, one moment. Why it is not connecting with that? I'll be just
You have to close this sharing and open the
yeah,
modular
yeah,
sharing.
yeah,
Sir.
yeah, yeah. I'm actually doing that. Now it's okay.
Yes, sir. Thank you.
Okay, oh, good. Okay, so actually one window only opening for this. Okay, that's only the problem here in Zoom especially. Okay, now see that these are the lengths of 40 laurel leaves. Okay, so that we have taken. Okay, this is very simple one, finding the descriptive statistics. And here we are covering here mean, median, mode, standard deviation, skewness, and kurtosis. Okay, these these things we actually call as descriptive statistics. Why means those who describe the phenomena, means it useful for describing the entire data distribution. Okay, so what is our purpose here is length of a particular leaves. Okay, that's only the thing, and we are going to identify the special characteristics that describe the entire distribution. Okay, that we are covering here. And are you able to see this? The party observations are there. I just given the name as X here. Okay, so and see that how I have made this name X, and you know these things and all you have learned in the beginning of the sessions. Okay, now I have made it here label, and this is a length of 40 laurel leaves. Okay, so I made this one as this length. Okay, so remaining I'm not touching. By means it is a quantified data, means that it's not a qualitative type. Okay, so I'm not giving any values here. Okay, so in when comes to the measure, okay, so now it is not comes under these two things. Okay, are you getting my point? Okay, when you are having this scaling variable, you already scaled this one. Okay, you need to press for scale. Okay, are you getting it, or still you have any doubt on this for selecting the measurement? Okay, please be active in the class so that I can move forward.
Yes, so clear.
Okay. So now what I can do, we know the things what we actually do here. Okay, this keep remember the steps how actually we do here. In analyze, you are getting most of the tools what actually we are going to cover in a basic level, and advanced levels also there. Some they have mentioned here neural networks, and some other simulation techniques, ROC, this and all comes under some advanced things. Okay, there are maybe when the versions are improving, so they are adding other things also. Okay, now you see here the you can go to these uh, frequencies also we can go. Okay, frequencies also we can go, or we can directly go to the descriptives also. Okay, both can be possible, but I'm going here with the frequencies how it will be. And so that this I am moving to these particular variables. And when you come for here when you come here, what I'm doing here is so here also there were percentages. Okay, but I'm not giving you that. And my main concern is to find out the measures of central tendency. Okay, why the measure central tendency it came is we actually deal the variables, deal the tools, whatever it is talking about the centrally located variables. Okay, this mean, median, mode, some this and all centrally located values of any distribution. Okay, so that this we actually call as measures of central tendency, and here measures of dispersion. Okay, so measures of central tendency, maybe here we can go for mean, median, mode, and sum also if required. Otherwise, there is no need to sum up the things. Okay, and see that in dispersion. Okay, what is standard deviation? How have you heard about this one?
Yes, sir. Sir, it's the
Yes, sir.
deviation between the data from the central tendency.
Okay, okay. So a sample point, how it deviated from the centrally located values. Okay, so we are finding out the deviation of sum of square deviations from the sample point, to its centrally located value, whether we consider mean, median, mode, that is different, but most probably we consider mean here. Okay, so it is a sum of squared deviations from the sample point to the centrally located value. That is the definition of standard deviation. Okay, and you see here these things, the definitions of this mean, median, mode. Anyone? Anyone can one can tell one. Okay, so it can be easily understandable to another people also. Okay, by means I am not going in deep in giving the formulas and all. Okay, I'm just going to explain you for what purpose we are utilizing this one. Okay, have you gone through these things, the definitions before that?
Yes, sir.
Good.
So here, mean is the actually average of the whole data. Median is the median value, that is the a medium value of the whole data, like the center one, and the mode is the most occurring value of the data.
Very good, very good. Okay, so and these things. Okay, so these are centrally located things. If you maybe when Anshul ma'am also taught you checking the normality. Okay, she said about these relations also, and she explained about skewness and kurtosis. Okay, so I'm just computing here all the descriptive statistics, means these tools, statistics. Okay, statistics is a set of tools, will explain you how the data is distributed. Okay, and variance, what is the definition of variance? It is a square root of standard deviation. Okay, so we actually both are the things that is the squared deviations from the sample point to the mean. Okay, range, what is range? Anyone can tell the range?
So the highest and the lowest value.
Good. It is a maximum minus minimum. We are also finding out these two things. Okay, what is standard error of mean? Anyone have any idea about it? Standard error. Any from you?
So can you please explain this?
So standard error, okay, is actually we are computing standard deviation. We are actually denoting standard deviation as sigma. Okay, when you compute standard error. Okay, so what is that is we are actually relating the deviation, this standard error about the mean, okay, of total observations it involves. Okay, so what actually the formula has given for standard error is sigma by root n. Okay, sigma by root n. Okay, so we are actually deviating from the we are computing standard deviation, and standard error is sigma by root n, means it is the most common thing when we go for some medical things. Why means very minute things also we can find out from this standard error. Okay, so by involving all the sample size, okay, that's only the difference. But most probably you go with the standard deviation only. Okay, don't go for standard error, but just keep remember the formula for standard error is sigma by root n. Okay, and you see this skewness and kurtosis. Skewness and kurtosis. I think you have seen that. You give me the details of that. That I'll move forward. I'll make this session is interactive so that it will be useful for you also.
Sir, can you just please tell me where the menu was for the accessing the frequency statistics? I think I lost it. So this menu, how do we reach this menu?
I'll give you again. Okay, so I'm coming here. Analyze. Okay, analyze descriptive statistics, and I'm going here for frequencies. Okay, and what I'm doing, are you able to see the screen?
Sir, yes, sir.
Yeah. Okay. So what I'm doing, I'm moving this variable to here. Okay, in the variable box, and I'm going to the statistics. Okay, that's only I'm doing here. Okay, and you see this,
Thank you,
I'm clicking. Okay, it will be available for you, and we can do that. And skewness and kurtosis also. This will tell you how the how symmetric your data is, and this is the peakiness of the curve. Okay, how the data is distributed. Okay, with a flatter thickness. This information it will be giving you for things. Okay, now I'm moving to the continue. Okay, if you want charts, okay, you can also go through the charts that is required for you. Okay, so if it is required, go for doing charts, otherwise not required. I'm just giving you the bar charts, how actually we do here. Okay, for frequencies only, I am telling this to show the bar chart. Okay, and maybe if you are going further, what actually you can do is you can go for one moment. Okay, for another things also in add-ons or in graphs. Okay, we are having legacy dialogues. Okay, are you able to see this legacy dialogues? Okay, if you want specifically all these things, bar, line, area, pie chart, box plot, everything it will be covered here. Scatter plot, everything will be covered here. Okay, if you want to go through this, you can also do this one, or and in when finding out this particular one, it has given that. Okay, so that I am
सर हेलो सर
हाँ
सर हिंदी में बताएंगे प्लीज
अयो Hindi, I don't know much. I don't know much, but so I'm from South, okay, Andhra Pradesh. But I understand the Hindi, but I'm unable to speak much of Hindi. Okay, so that is the main problem for me. So please bear with me. I'm unable to meet your requirement. Okay, and format that is not required. Okay, this is actually going for ascending values that automatically takes, and multiple variables that will compare the variables, that no need to give anything here. And you see that you need to think about when it is coming, this dialog box is coming, what you can do, you have to move this variable to variable session, variable box, and go for statistics. You click on all the measures of central tendency, dispersion, and distribution. Okay, three things you need to check, and that's enough for the finding out the descriptive statistics. Okay, charts, in charts, you can select anyone, or if you don't want, there is nothing required. And on chart values are frequencies. That's only they defined here. So I'm continuing. And this is the most important thing. You need to click on this. Okay, if you remove this, then frequency table will not be presented. Okay, so please be careful. It automatically there, but if you are maybe by when you are clicking, if you are making any problem, then it is and you need to click on this one so that it display the frequency tables. Are you clear about up to now? Are you clear, or one more explanation about this?
Yes, sir, clear.
Clear.
Oh, okay, good.
Yes, sir.
Okay, so I am moving for finding out this output. Okay, are you able to see this output?
No,
You
sir.
have to share the
No,
output
sir.
screen.
Yeah.
Output is not coming.
No, sir.
Okay.
You have to share that screen again.
Means every time we need to stop share. What is this at all?
Yes. Yes, sir.
There must be option of sharing the entire screen.
Oh, that is not coming. I'm checking
Okay.
that. Okay, it is not coming. It is showing all the things, all the bugs what you required. Okay, I'll check with that whether if you want that, then I'll be going through that. Okay, so here we actually come here. So those who are working with the syntax, okay, those who are working with the syntax, you can use this syntax. This is the actually syntax for what we are doing with a menu driven things. Okay, this in this we actually utilizing whatever we required. Okay, the statistics. Okay, whatever we required, frequencies variable is here x. Okay, this is actually syntax for what we actually done with the menu driven things. Okay, statistics, std, standard deviation, variance, range, minimum, maximum. Okay, so this and the standard error of mean, median, mode, sum, skewness. Okay, standard error of skewness, kurtosis, standard error, this and all. This is actually we can write as a code here. Okay, that is actually log. If you go for here, it is available. Okay, no need of these things to remember all these things. And what we required is we required frequencies, and this is actually where I saved this particular particular SPSS file. And what we require, okay, I have given length of 40 laurel leaves. Okay, so how many numbers here? N is 40. There is no missing values. Okay, now what actually we can do, we have got the information about mean, standard error of mean, median, mode, standard deviation, variance, skewness, kurtosis, range, minimum, maximum, sum. Okay, so here now you can tell me the mean is for 146.8. Okay, what it means? What it means? What it means? Okay, may you tell me the description about mean by for this data? Anyone?
146.8.
That's only, but how you explain? Okay, the average length of 40 laurel leaves is 146.8. Okay, so whenever you write something about these tools, okay, don't keep only values. Okay, write the complete information about each and every tool. The description you need to explain to them. Okay, that is most important. Then only people think that you are understanding the concepts. Otherwise, this is not. Okay, so what is median here? 146. Mode is 135. Okay, what is mode? How many times? How many times it is repeated? There were much of the things. Okay, if you see here, 135. Okay, how many times it repeated?
3 times, and is the most among all the lengths.
Most among the all the frequencies. So that displayed here. Okay, median, which cuts the entire distribution, means this is the median for this particular length of 40 laurel leaves. Okay, standard deviation. Okay, see, standard deviation is this. Okay, that means there is a deviation of 13.05 from the mean. Okay, for the entire distribution. Okay, so what we can write here, 146.8 plus or minus 13.0505. Okay, so that is the range of length of this laurel leaves. Okay, are you getting my point?
Sir, it's clear.
Yes, sir.
Okay, so what is skewness? Anyone can tell? But the value is 0.189. Is it a positive skewed or negatively skewed?
Negatively skewed.
Positive.
Positively skewed.
Positive.
What is kurtosis here? Kurtosis value?
Minus point.
Minus. Okay, so what you can tell
It
from
is
this?
less than 3, then it can be mesokartic.
Okay. Okay, so these are the things you need to remember. Range is this. Okay, the maximum of minus and maximum minus minimum. Okay, this is the range. This much range only the entire distribution is there. Okay, minimum is 119 and maximum is 176. This is 176 minus 119. Okay, that is 57 is coming. Okay, are you clear about this descriptive statistics?
Yeah.
So here this is a cumulative things. We can accumulate the frequencies only. We ask. Okay, that has generated the cumulative things, and each and every time it is adding one more value to that. Okay, so that it should be 100% in nature. Okay, and see that this actually has given the bar chart. Okay, so how the frequencies are coming here, and how the lengths are the particular frequency. Okay, so that he has defined here. Okay, so that you can see with a one go. Okay, without seeing the data, means instead of seeing the complete information. Okay, so the about the table, but you are visualizing in a clearer way. Okay, that's why visualization techniques are so much useful for explaining a huge values of tables. Okay, so we actually be expertised in visualizing the things. Okay, to explain to the real world. Okay, so that we are covered here. This is the thing about finding out the frequencies. Now we are going for ungrouped data, that frequency data that actually we do here. So far, any doubt, or if you are clear with that, I will go for that, and I'll cover that.
This is clear, sir.
Okay. So I'm just minimizing this. I think it's not showing here, no, the SPSS data editor. I'm
No,
again
sir.
I'm again closing. My entire screen is not coming. That's only the thing here. Wait, one moment. I'll. Okay. Yeah, I am now selected many of them so that it will be clear to us. Okay, so now is it visible to you?
Yes, sir.
Yes, sir.
Good. Now I can go here, and this also now visible to you, no?
Yes, sir.
Yes, sir.
So this is the data for frequency values of class marks. Okay, I am coming to you. Right. Okay, see, I'm here explaining you about the data. Okay, and this is actually there are 480 students, school children. This is the data about IQs, intelligent coefficient of. Mute yourself, please. Okay, so that cannot be
The
disturbed.
screen is not visible SPSS.
It's not visible.
No, sir.
One. All the times I'm doing here, sharing the screen. Okay. Now,
Yes,
Yes,
sir.
sir. Fine.
this data is IQs of 480 school children. Okay, in certain school. Okay, we are finding out here the frequencies, and by this we are going to find out our descriptive statistics. Okay, so for particular this type of data, okay, we need to be very careful. Okay, why means it is nothing but 70 to 73, 74 to 77, 78 to 81. Okay, this is the frequency data. Okay, so we are writing the upper bounds of this particular frequencies. Okay, so that it will be covered with that. Okay, so how you deviate when you are giving this range for equal range for each and every sample point, and we are finding out the frequencies here. Okay, how we can go about it? Okay, what actually we can do here when you are finding out descriptive statistics for a frequency data.
Sir, can you just show the variable view so that
I'm showing. Okay, so this is actually class marks. Okay, so class marks and the frequencies. Okay, so I have given you here the one moment. It is 1 moment. I'm giving you here. This is not a yeah, it is marks only, class marks only. Okay, so and the frequencies. Okay, so these two things. Okay, this actually we have given the marks of a different range. Okay, that frequency we have given, and what are the students how they got into the particular range. Okay, now these two becomes a scale measurement, and what actually we can do here, what you are going to weight the cases. Okay, that is very much important here. Okay, so on what basis you are finding out the descriptive statistics. Okay, that is most important for you. For here, what actually we are doing is we are doing here, we are weighting the cases of frequencies for finding out the for finding out the for finding out the descriptive statistics for the class marks. Okay, that we are doing here. Now I'm going for weighting the cases. Okay, so what in what sense we are weighting here is that is the frequencies. Okay, so we are moving to the weight cases now. Okay, for finding out the descriptive statistics for frequency data. Okay, now I'm going for data. Okay, please keep remember, this is a very much important thing. Means when you do these type of things, and you will be able to understand how the range can be given for a particular parameter. Okay, I'm doing here weight cases. Okay, weight cases, what actually we are doing here, these frequencies are weighted by. Okay, frequency variables are the weights for particular information, so that we are weighting the cases by the frequencies. Okay, so that's only we are finding out the descriptive statistics for these frequency tables. And here, when you weight the cases, that always comes under this one, and it will be easy for you to compute the descriptive statistics. Okay, are you clear about this? Okay, so when you weight the cases, what actually it will give is this it is visible to you on another screen, output screen.
No, sir.
Every time if you are checking like this, it will time taken. Okay, so you see that here we are weighted by variable 2. Okay, that is actually frequencies. Okay, so we are finding out descriptive statistics with the frequencies by weighting by means of these frequencies. Okay, so that we are calling here as a as a as a as a descriptive statistics for the frequencies data. Okay, so if you see here, weight by this particular one, so we can now, it can be possible to give that to compute the descriptive statistics. Otherwise, if you are not weighting this for a frequency data, it will not weighted by these particular frequencies. So you are getting incorrect values, and you are doing incorrect procedure. Okay, so most of the time we try to avoid this frequency type of data for the other social scientists, but you need to remember why actually we do this one descriptive statistics for frequency data also, so that I am covering here. Keep remember that these steps are very much useful for you whenever you are dealing with the such type of parameters here. Okay, I'm just stop sharing, and I'm opening now the file. Okay, now I come here. So this is the data view, so that this already these frequencies are fixed by weighted by the cases. Y means it those, so it will consider. Okay, so this value will be in this range of this one, so that it will give you the results. Otherwise, it will not it will not give the any results. Okay, so you see that now. Okay, so when you are not taking the range also, then what you are doing? Okay, for 70 is 4 times, 74 is 9 times, 78 is 16 times. That also it will take. Okay, if you are not weighting these cases, it will not consider these frequencies. Okay, how many it is coming? I'll see. I'll show you. Okay, how it comes. Okay, now same procedure for finding out this also, descriptive statistics frequencies. Okay, so we already weighted, means we need to consider 74 times, 74 9 times, 78 16 times, 82 28 times. Okay, that like that we need to consider here. So we weighted with the frequencies. Okay, those who are having doubt, you can ask me many times also. There is no problem. I'm here to explain you the things. Okay, so
data needs to be arranged in ascending order for this.
yeah, it is better to make ascending order. Okay, if you not also, there is no problem. but better to make ascending order. Okay, it will take, even though if you are not making ascending order, here some format is there. One moment, I'll show you here. Here's format is there, ascending values. Okay.
Okay, sir, got it.
Okay, so not required to give this here, and it will take automatically with ascending orders. Okay, so now we are weighted this frequencies, so there is no need of doing anything with this now. We already weighted, that means to consider 74 times, 74 9 times, like that it is going on. Okay, so we need to find out descriptive statistics for the class marks, means the for checking the intelligence coefficients of students, how they got their marks. Okay, so now the same procedure will be there, and we are clicking all the information. Standard of mean is not required for you. Okay, I'm clicking all the things. Okay, so charts. Okay, charts are not required, but I'm just giving you for the information. Okay, format already given, ascending order, multiple variables. We need to compare the variables. This is not required. This automatically therefore in these things. Okay, now display the frequency tables are very much important. We need to click on this display frequency tables. Okay, are you clear about this one up to now?
Yes, sir.
Okay, so I'm going forward. Okay, now you are unable to see the output screen now. I'm going output screen. Okay, now class marks. Okay, so it has here. Okay, and see that the mean of value of this one and the median value. Okay, so if you observe very closely, okay, median value. Okay, what is median value here? 94. How many times it repeated? How many times?
85.
85. This is the value which cuts the entire distribution into two parts. Okay, so what are the frequency here? The total of frequency. This is 480. Okay, students already came with the 480. Okay, and this cuts the entire distribution into two parts, and also this is the highest frequency. Okay, mode also they have given here, and the standard deviation. Okay, the range of these things, or this one. Okay, and skewness is 0.177. okay, it is a positively skewed one. What is kurtosis here? 0.022, means it is nearer to the both skewness and kurtosis values are nearer to the symmetry. Okay, if you see here the graph, okay, what it looks, okay, it is nearly looking about the symmetric one. Okay, and see that case is weighted by frequency. That if you are not doing, then it will not consider the cases what actually we have given. Okay, so we need to weight the cases to find out the descriptive statistics for frequency data. Okay, are you getting my point? Still anyone have doubt on this?
Can you explain in the starting why did you take the weight class?
Why means, see, before I'll be showing you here for are you able to see this?
Whose screen is available right now?
This one, X. Output screen only visible.
Yes, sir. Yes, sir. The output screen is visible right now.
Right on. Now, if you see here, you have given only the ungrouped one. Okay, of this 40 observations. Okay, what is the difference between this and that? Okay, so you have mentioned here this particular frequency have come for this many times. So you calculate the descriptive statistics accordingly. Okay, that's you have represented there. Okay, if you are not doing also it will consider. But when they have given in the problem, okay, how you can do it? Okay, instead of writing the values 2 times 3 times, see, you need to write the values for the second case. I'll show you. Okay, for this you need to write as, and if it is ungrouped means 70, you need to write 4 times. Okay, at the same time, one moment. Why means it will not open? Yeah. Okay, now this one, when you are taking ungrouped data, okay, what happens? You need to type this 94 85 times, so that only it will give you the descriptive statistics for ungrouped data. But here you are minimizing the time, okay, for computing the descriptive statistics for frequency data. Instead of writing hundreds means 480 numbers you need to repeat here, 480 students. Okay, are you getting this? Why we are minimizing the time and as well as the computation part.
Sir, understood. Understood, sir. Thank you. Okay.
Okay, so this is the descriptive statistics for ungrouped data and the frequency data. Okay, now I am moving to the correlation. I'll be opening that. Okay, now I am coming here for finding out the correlation. My screen is visible to you?
Yes, sir.
Okay. So what I have taken here is the variables. Okay, one is age and another is blood pressure. Okay, so 2 variables I have taken, whether these 2 things. Okay, so age and blood pressure, okay, how they are related. Okay, so I have taken age and blood pressure of 12 women and finding out the correlation of both of them, how they are correlated each other. Okay, you know the definition of correlation, anyone?
Sir, it's the relationship between the two variables, how they are interrelated to each other.
Okay, very good. How many types of correlation? Anyone?
So one is rank order correlation.
No. You are telling types of correlation.
Okay.
Okay, how the correlation will be defined, whether it is a the when positive or negative. Okay, so
Scattered and unscattered.
no. This is I'm telling you. Okay, so the types of correlation is it's a different type for ranking the things. Okay, that is correlation type. Okay, now how the relationship, okay, to find out is, okay, one is positive correlation. Okay, so the negative correlation and the zero correlation here. Okay, so how the data is distributed for positive correlation is, that means if one value means one variable is increasing, okay, another variable also increases towards the first variable. Okay, and if it is negative, maybe both are in opposite directions. Okay, I'll be telling you the examples of positive correlation. Okay, so when the salary is increasing, okay, automatically expenses also will increase. Okay, so and the negative, if volume and pressure, okay, if you take both the variables, if volume is high, then the pressure will be low. Okay, so the negative things, maybe demand and supply also there. Here you can take that variables also as a negative things. Okay, what can you tell me, anyone, how the zero correlation is coming here? What is meant for zero correlation? Maybe you can define any of the relation. Okay, you can tell the zero correlation. Anyone? When you are taking, when you want to find out a relationship between two variables, what actually we do here is they are somewhat related to uh, the particular entity. Okay, if not relating, okay, means population of India and GDP of America. If you take that, okay, what is the relation between them? What is the relation between them? Okay, there is no relation, that we actually call as zero correlation, or we can call it as a nonsense correlation also. Okay, so we don't have any relations among two variables. So how you can relate? Okay, most of the times we relate the correlation for two variables, but the two variables are related to each other. Okay, then only we compute the correlation coefficient. Okay, are you understood the topic, how actually we are doing here?
Yes, sir.
Okay, so I have taken here age and the blood pressure of women. Okay, so this is the values for that. Okay, this is simplest way is here. Okay, anyone know the correlation formula? Correlation formula. The correlation formula is covariance of x and y by standard deviation of x and the standard deviation of y. Okay, in the broader sense, okay, we actually go for it. I'll be giving you need a theoretical explanation for this, or I can move forward to the correlation what we do in SPSS. I means I have some material there, but I'm going to net for giving the types. I'll be showing you, or I think I'll be showing you. We have discussed about the positive and negative correlations. No, I'll be showing you that how actually we can write down. This is my screen is not visible to you, no? I'll be coming to you. And range of correlation also, okay, -1 to +1. Okay, if it is 0, there is no correlation. If it is -1 to 0, then there will be negative correlation. And 1 0 to 1, it will be representing as a positive correlation. If you see here, okay, what is 0 correlation represents? Okay, are you able to see this graph?
Yes, sir.
Okay, so perfect positive, 0 correlation, perfect negative. When the correlation value is 1, okay, then we can observe means what is this line? Anyone can know the line? What is this line? Linear line. Can anybody know this line?
Equity line.
No, it is actually the average line. Okay, so sample points also fall. Maybe most of the sample points are fall under this particular line. Okay, are you getting this? Okay, so we are calling it. It has a perfect positive. Okay, when the correlation value is 1, so we are actually calling this as a perfect positive correlation. Okay, and 0 correlation, I have given you the explanations how the spread of the scatter plots. Okay, so I'll be showing you a scatter plot also, how we explain this particular our data also. Okay, perfect negative means, so this is coming in a opposite direction. Okay, are you getting my point? This is the perfect positive correlation and perfect negative. When the correlation value is 1, is a perfect positive. Correlation value is 0, is 0 correlation. -1 is perfect negative correlation. And I'll show you here. You can see that how what is this? What is this? Okay, how it is located now? Someone can tell me that. What is the type of correlation here? What is the type of correlation here?
So negative correlation.
No. Positive correlation. Okay, it is going. Okay, one variable increasing. Okay, SAT score is increasing. Then this also college GPA is also going to increase in this direction. Okay, linearly it is increasing linearly. Okay, and if you see here so this you need to remember. I'll copy and paste this one in chat box also. That means it is useful for you. Okay, so what is charts? I'll be just looking about this. Okay, and see that correlation coefficient, correlation strength, correlation type. Okay, so most of them will be confusing how to interpret the correlation. Okay, that is the thing you need to understand here. Okay, this is when the correlation value is minus 0.72 -1, then correlation strength is very strong. That means both the variables are in a opposite direction, but it is a very strong one. Okay, this is mostly negative. Okay, high negative we can say. Okay, so strong, moderate, weak. Okay, they have defined this one. Okay, this is useful for you when you're finding out the correlation for that. Okay, that's why I have given in the chat box also. Those who are going to see this, you can also see that in your leisure time. Okay, and you see that the weak, moderate, strong, and very strong correlations. Okay, how you can tell whether they are positive or negative? Okay, all the times when it is crosses the negativeness, then we call as this negative correlation. And if it is 0 to 1, okay, this all comes under positive things only. But what is the thing we need to remember is how correlation means, whether it is a weak, whether it is a moderate or strong, very strong, that you need to define by yourself. Okay, that they have defined here. And for any work you are doing, so you need to explain it very clearly. Okay, how much strong your relationship between the other variables. Okay, so if you see here, perfect positive correlation that we have seen here, perfect positive, and see that those are all the sample points in a same line, and see this also perfect negative correlation. This also this also this also in the same line with the opposite direction. Okay, so and see high positive correlation, how it is coming. Okay, so the sample points are nearby the mean line, average line. Okay, if you see here, distance between the sample point and the average line. Okay, when we discuss about the standard deviation, okay, that also it comes here. Okay, so that's only the formula is covariance of xy. That means, but that means combined variance of both the variables and divided by their deviation. Okay, so we are dealing here bivariate frequency data, and for that, for bivariate data of x and y, and see that each sample point we are finding out the deviation from the mean line. Okay, so this will calculate the standard deviation. Okay, so if someone asks you the question about standard deviation, what you need to tell is, this is the I told you sum of square deviations from a sample point to their mean value. Okay, so this is the definition you need to tell to the people. Okay, those who asked you about the standard deviation. Okay, so in high positive correlation, what it means? Okay, this is the sample points are closer to the mean line. Okay, here also, but it is going with a negative direction, it is going with a positive direction. Okay, low positive relation for positive correlation, how it is coming? So the sample points are much deviated from the mean line. Okay, so are you getting it? Okay, dispersed, it is more dispersed than this one. Okay, low positive correlation and the high positive correlation. Okay, and low negative and high negative. You see that the sample points are dispersed more than this. Okay, so that's why our correlation value also becoming low. Okay, so they have given with the different types also. We actually see, and also I'm covering here two types of correlations here, and one is Pearson R, that is linear, and so see that. Okay, actually the definition of correlation is to find out the relationship between, okay, linear relationship between two quantitative variables. You see that the measurement, okay, interval and the ratio scales only we are mostly dealing for this one. Okay, and when you are going for the ordinal case, okay, when you are ranking them, okay, that also you can do with the correlation with a different type. Okay, Spearman's correlation for ranking variables. Okay, that we can do, that is non-linear case. Okay, we can apply this Spearman row with the two ordinal interval ratio variables, three variables. But Pearson correlation is only meant for interval and ratio variables only. Okay, and see data distribution, we assume that data follows normal distribution. Okay, when we are doing this correlation, we assume that the normal distribution, it follows normal distribution. Okay, but here any of the distribution. Okay, these two things I am actually going to cover. Okay, there are other types of correlations also there, but I am not covering most of them here. Okay, only two. as per your requirement, that is enough for you to understand how the correlation will come into the picture. Okay, and see that the correlation formula. Okay, this is actually covariance of xy by standard deviation of x and standard deviation of y. If you take rxy values, okay, and see that this we are representing it as a small r, that is the strength of the correlation between the variables x and y. Okay, and n is your sample size and the sum of what follows. Okay, so this actually we actually do here, and every x minus variable value. Okay, so this xy, you need to remember, this is the product of each x and y variables. Okay, so this is actually we are dealing with this particular formula for finding out the things, but when you are doing in SPSS, it is very much easy for you. Only few steps will be there, but before going to the steps, you need to understand how these actually are coming into the picture, and how we are explaining that. Okay, this actually we are calling it as a rxy equal to covariance of xy by, this is actually standard deviation, sample standard deviation we actually call as. If you are taking population, then it is a sigma x and sigma y, and when you are dealing only the sample population, okay, so sample, then we are actually moving to the s and sy, sx and sy. Okay, so are you clear about this correlation? I can go for SPSS.
Yes, sir.
Okay, wait. So what I have taken here, I have taken age and blood pressure, how they related each other for we have taken 12 women for finding out this particular one. Okay, so what happens when we go for the steps? What actually we do here is see that the correlate is there. Okay, are you able to see my screen?
Yes, sir.
Okay, so correlate is there.
Yes.
What actually we are covering? Okay, so bivariate, we are going here, and see that we are actually finding out, means two variables needed for finding out the correlation. So all the quantitative type, two things also quantitative type. So we are moving these two variables into the box, and the options, and the options also you can go for only finding out the means and standard deviation. There is nothing required for this, but if you want to tell more about this particular data, you can also go through this particular standard deviation, means and standard deviations. Okay, so missing values exclude cases pairwise. Okay, that's only pairwise. Why you are writing pairwise here? Anyone? Pairwise.
So that like if age is not taken into consideration, the blood pressure is also.
Right. That means if one value is missing for one variable, other variable is present, but it will exclude the value. Okay. So and style also not required for you. Only options, go to options and select this one, means and standard deviation. If not required also, there is no problem. If you are not selecting this else, there is no problem. Okay, and see here, the main thing here, you need to check about the correlation coefficients, and these three things are presented here. Okay, you need to select which one you want. Okay, which one you want. Okay, so I want here Pearson correlation. Okay, and the test of significance is I'm actually going for two-tailed one, and see, this is very much important here. Flag significant correlations. Okay, whether it is a significant or not. Okay, how you can flag Okay, the beauty of SPSS is that will plug your significant correlations. Okay, with the different degrees of freedom. Okay, that means 95% confidence levels. No, so that will be giving you the information about the significant whether the relation is significant or not. Okay, are you okay with this, or can I explain one more time the steps?
Sir, this is fine.
Okay, good. I'm going to the okay. So I need to close the sharing and I'm opening again. See, correlations. Okay, correlations, what it means. Okay, it has given standard deviation, means and standard deviation. Okay, and you can, by this you can tell the range of the range of a particular information, means the variable x and variable y. Okay, so 52 plus or minus 11.87. Okay, and blood pressure range also 140 plus or minus 15.07. Okay, so now you see here, okay, age and blood pressure, and this is like looking like a 2x2 contingency table. Okay, and you see here, okay, this is what is the value here. What is the value here?
0.896.
0.896.
Yeah, 0.896. Okay, this is your correlation between age and blood pressure. Okay, when you compute age versus age, there will be no point to compute the particular one. Okay, so we want to compute the other variable. Okay, how it comes. Okay, when you compute this blood pressure also, this will be 1. Okay, that blindly you can say. Okay, no need of computing this one separately. Okay, so what we are discussing here, we are finding out the relationship between age and the blood pressure of a woman. Okay, so that 12 women. So what is the correlation here?
A strong correlation.
It is a strong positive, very strong correlation, and it is a positive correlation, a strong positive correlation among these two variables. Okay, and that is the significant levels also. This is significant at one, that is 0.01 level. It is nothing but it is very sensitive to interpret. Okay, so that is 0.90. Previously we always take for any of the data 95% of the confidence levels, but here it is more significant here to find the relations, and what actually we have given 0.01 level, that is nothing but 99.99%. Okay, so that's only the thing. Okay, you need to remember that. Okay, are you getting this? Now we can go for giving it in a scatter plot. I'll show you that how it comes.
Sir, what is this two-tailed and one-tailed type of significance?
So that actually we are considering here as two-tailed means we are considering both the dimensions, both the directions. Okay, one-tailed means if your data means one side, positive side only, we need to consider. Okay, negative side only we need to consider. But here when you are assuming data is normally distributed, okay, so we are considering two types, means positive and negative types. Okay, here our correlation value also it is comes under -1 to +1, so we are considering two tails. Okay, I'll explain you more when we come for hypothesis testing, t-test, f-test, t-test, ANOVA. Okay, then I'll explain you more clearly, okay, about why we consider two tails. Okay.
Okay, thank you.
Yeah. Okay, so this is the nothing but the correlation among these age and blood pressure. Okay, so I'll plot this one by using scatter plot. Okay, so graphs also we can go directly, and are you able to see my screen?
Yes, sir.
Okay, so this is a scatter plot. Okay, I need only simple scatter. Okay, so that you need to remember here. I'm going once again. Graphs, legacy dialogues, and scatter plot. And here I am selecting simple scatter. Okay, there were many types of things are there, but we don't require that much for two variables. Okay, I'll be showing you here a simple scatter one. Okay, and see that here you need to understand it very clearly. Okay, so when you are dealing with any of the values, and you need to focus very much on how to represent the values. Okay, so by age, okay, here your maybe anyone we can plot on any axis, but when you are coming for a regression, maybe for this we can do that. Okay, age in x, and blood pressure in y variable. So as age also displays in the x axis. Okay, someone can mute, please mute your things. Okay, and y is y axis. We are making it as a blood pressure. Okay, and you see that you can make the titles also. Okay, titles also. Okay, there is no need of writing, but you can make the title for both the lines. Okay, well, it will automatically generate whatever we have given, and you, if you want to make the title, you can make the title. There is no need of writing it again. But if you want a clear picture, then you can go for writing titles. Okay, options, there is nothing to select here. Okay, I'm just clicking this one. Okay, I'll show you now. I'll show you now this graph, this scatter diagram. Okay, are you able to see this diagram, scatter diagram?
Yes, sir.
Okay, age,
Yes.
age versus blood pressure. Okay, age versus blood pressure. Okay, that is the thing, we actually go for it. And when it comes for regression, I'll be giving you about the line. Okay, how the line will come, and what is the meaning of that line, that I'll explain you. I have given you a idea about what is line meant for, and I'll be explaining you more clearly when regression comes. Okay, so age and the blood pressure. Okay, so and you see that the if you compute the compute this, you see that the range of this one, or by seeing this also you can tell, okay, how they are deviated, how much they are deviated from their mean, and how the relationship between. And by looking about this particular scatter plot, we are able to identify what type of correlation among the two variables. Okay, is it clear to you, or we can go for Spearman's rank correlation?
Yes, sir.
Okay, so this is linear relationship between two variables. Okay, so here only quantitative things, and then the variable type, measurement types, or interval and ratio types only, we are able to perform Pearson's correlation. Okay, now I'm moving to the Spearman's correlation. Actually, why we use Spearman correlation is when the data has given to you. Okay, when you are ranking them. Okay, so in maybe entrance examination, or any cutoff when you want to give, we need to rank such things. Okay, means some in judgment, in judgments, no, like any competitions, we need to rank them in an order. Okay, so in that cases, how we compute the correlation among the among the variables. Okay, so for that Spearman has developed a formula, and he has given a very good formula to suit for the ordinal cases. Why means ordinal means we are ranking the variables. Okay, levels we are ranking there. Okay, so for that it will be best suitable for finding out the correlation. Okay. Okay, I'll go through that. I'll just explain you how it comes. I'm just presenting my screen now. I'm coming for Spearman rank correlation. Okay, and see that the symbols also, they are different for Spearman's and Pearson correlation coefficients, and why we actually use here. Okay, so here also our correlation is involved, but how actually we do here is we are ranking the variables data. Okay, we are ranking the variables data, and what is the formula? Okay, this is the formula. Okay, RS is given by 1 minus 6 summation di square by n cube minus n. Okay, this is the formula. This runs with the background. Okay, when you compute manually, you'll be able to see this one, but you can go, maybe there were many research methodology books and many literature available for finding out these correlations manually, and with Excel tool also you can find out this Spearman correlation. Okay, and see that the di is nothing but difference between the rank of variables, okay, for each pair, and this is sum of square differences. Okay, so here also we are summing up for finding out the correlation. Okay, and remaining things are same, means the range of correlation, Spearman correlation is same for this one also. Okay, -1 to +1. Okay, so if you have correlation coefficient of 1, all of the rankings for each variable match up for every data pair. Okay, -1 is, it is exactly opposite to the rank. Okay, and the same thing. Okay, same thing what actually we covered for the for the for the for the Pearson correlation. This is also the same thing. Okay, we are doing here, and this is very much useful when you are ranking the system. Okay, when your data is involved in a ranking or ordinal cases, so you can utilize this correlation for finding out the relationship between the variables. Okay, so without delay, I'll be going to this SPSS window, and here what actually the problem I have taken is, and here this is a laboratory and the lecture. Okay, how 10 students, okay, were ranked according to their achievements in both the lecture and laboratory things. Okay, that's only we are any particular course. Okay, how they performed in ranks, that's only here we are defining. Okay, so we are moving to the data view. Okay, so these are the ranks given by the teacher. Okay, how the performance of each student. Okay, in laboratory and the lecture means theory, we can tell. Okay, theory and practical also we can also tell the both the things. Okay, are you able to understand this data first?
Yes, sir.
Okay, so this one actually we are covering here. This is laboratory, and this is the ranks of each student in laboratory and lecture. Okay, so and you see here, this is the ranks they have given from from 1 to 10. Okay, now I'm moving to the same things. Okay, so you need to remember the formula for that. Okay, if anyone asks you, okay, you can tell, but if the usual definition without for understanding to layman, we need to tell the for ranking these for ranking variables. Okay, for ordinal data. Okay, we can utilize this one for normal data also. Okay, it will rank. Okay, for normal data also it will rank automatically, and it will give you the Spearman correlation for that. Okay, and see here, this already ranked data. We are moving to the doing the score correlation, Spearman correlation. Okay, now the same thing here, correlate and bivariate, and both the variables we are dropping down to the variable box, and the options if you want to compute means that is not required for this one. Okay, so this is already ranked. Okay, don't go for finding out this mean and standard deviations here. Okay, this is the ranked data. This will be very problematic to you when you compute this one. For ordinal cases, you need to compute median or quartiles. Okay, how the opinions are there. Okay, don't go for selecting anything here. This automatically there, and you need to remove this one. Pearson correlation is for quantitative type data. Okay, and that is a ratio or interval scale. Okay, what actually we are doing here is Spearman correlation. We are clicking on that and plug the significant correlations. Okay, are you clear about the steps what I'm doing, or still you have any doubt?
No, sir, it's clear.
Okay, good. Those who are feeling uncomfortable, I'm very sorry, I'm unable to speak in Hindi. Okay, but I'll give most of the explanation, and whichever the things I covered today, and whatever the time you find, maybe you can contact me at any time. I'll give my number and mail to Jilpi sir, so that you will be contacted at any time. I'll explain you very clearly. Those who are not understanding here, or maybe if you have finding out some doubts, okay, so you can see that, and this video is available for you in the Mindshare Yuva YouTube channel. Okay, you can access this one for any time, I think. Okay, so these are the steps we actually do here, bivariate correlations, Spearmans, and plug significant correlations. Okay, so I need to close here to open this
The,
window.
the variable type was ordinal, right?
Yeah, variable type is ordinal, that also we can select here. Okay, so okay, I'll perform this one. One moment, it is not coming. Are you able to see my screen? I'm changing here.
Yes, sir.
Okay. Now I saved now. Now it will come automatically. Oh, one moment. It is showing here only the scale things. I'll just no, it's not coming here. I'll just close and open this one. It will come. Oh, one moment. Okay, now this came. Okay, now it is showing here ordinal. Are you able to see the screen?
Yes, sir.
Okay, good.
Yes, sir.
Oh, good. Thank you. So I'm now moving to the output things. Okay, now I have to present the output screen for you. Okay, you see here the spearman's row. Okay, what happens here? What is the value here? What is the value?
0.855.
Okay, that means what is this? What is the correlation of every student in practical and theory class?
Highly positive.
Okay, highly positive and very strong correlation between the theory and practical marks of a student. Okay, ranks of a student, that also you can say. Okay, so interpretation is very much important for you, so that you need to always remember how you do the interpretation for any of the topic. Okay, so 4:48 now. Those who have any doubt, you can ask me. Otherwise, if you want me to cover one more topic, I'll cover for today. Otherwise, we can close this session.
So what is that last topic?
It is a partial correlation.
So it would be better if we understand all together. Otherwise,
Okay.
we would break.
Okay, no problem. I am covering that also now. And you see here, stop sharing my screen. I'll be going through this partial correlation. Anyone know about partial correlation?
Okay.
Actually, in some practical point of view, someone is disturbing our class.
One Sushma Kumari needs to mute mic. Sushma Kumari ji.
Oh, yes.
Okay, thank you, thank you. What is partial correlation is? Are you able to see my screen?
No, sir.
Oh, one moment. I did not present the screen. Wait. Okay. Now.
It is visible, sir.
Okay. So what actually we do here? for suppose when you want to go for finding out the correlation more than the variables, more than two variables, okay, by controlling with one variable. Okay, there were many situations which are forcing us to control a variable, and this correlation is meant for finding out the relationship between two variables only. But there were some variables which influence, okay, which influence the relation among the two variables. Okay, for that reason we are doing partial correlation. Okay, so when you want to fix some value, some variable here to find out the other two things, okay, it is a controlling variable for the two remaining variables. Okay, so most of the times in a practical situations there were many variables which controls the relation among the two variables. Okay, there are many forces will involve in a practical sense. Okay, that we actually go through this particular one by controlling one element. Okay, and we are finding out two variables correlation here. Okay, so that actually I'm not going in deep, but when you want to face these particular things, just to go for typing partial correlation in the net. Okay, how you compute you can go through the theory. Okay, how actually why we are using this one. So you will be getting an idea about this one. We don't have much time to give you more in detail. Maybe if the FDP or this course will be in morning to evening, then we can cover theory as well as the things. But I'm unable to cover the theory part here. But I'm telling you, okay, in practical situations there were many variables which influence which influence the which influence the relation between two variables. Okay, there are other variables. Okay, I am restricted here up to two variables only, up to three variables only. That means one we are actually making constant and the others we are finding out. Okay, so the steps are here is the same thing, correlation, and see that R partial. Okay, if you see very
Sir,
clearly.
so can you just show the data view of this partial correlation?
Okay, here you see that this is the quantitative type only. Okay, okay, so that there is no problem. So that I have given here.
Thank you, sir. Thank you.
Yes. Okay. And see that partial, that is nothing but by fixing one variable we are finding out the relation between two variables. And if you see, it is very small in, I think very small it is showing. Okay, R12.3. okay, are you able to see that screen? It is a very minor. Okay, when you open this one, R12.3, it is very minor. If you closely observe only, you will be getting that. Are you able to see that?
Yes, sir. Yes.
Okay, so when you go for bivariate, you see that bivariate, what it is coming? Okay, only two variables, R12. But here we are fixing R12.3, means we are fixing one variable and finding out the relationship between other variables. Okay, that is actually partial. Now, if it comes here, what actually we are doing? We are going to compute the correlation for these two variables only when we have control over x3. Okay. Okay, so you can how many correlations will come here? You tell me the combinations.
Sir, two.
No, three combinations will come. We need to find it out separately. That means this is one combination I'm doing here. that is x1 x2 by fixing the making the controlling variable x3. Okay, so and next one x1 x3 by controlling with x2, and x2 x3 by controlling the x1. Okay, we need to find out 3 correlations here. That's only we are telling this is the partial one. Okay, this is not the complete one. Okay, someone is here controlling our relationship, that the 2 variable relationship. That's only the thing here. Okay, that okay, maybe in your example also we can do that. We can tell that, and maybe if you see that for normal example, I'm telling you, I am the instructor to you, you are the participant. Okay, both are here, and who is controlling us? Who is controlling us? Okay, host is controlling us. Okay, so host can do anything. Okay, if you want to remove you from the meeting, that also possible. Okay, like that, if some situations there are things, okay, which controls. Okay, if you want to find out some GDP, then what it means? Okay, that GDP is control for population and also the income of the total income of the country. Okay, like that, the some situations come, you need to understand why we actually go for partial correlation.
Sir, for example, income, GDP, and consumption.
So like that, we need to have a control over the means in reality we will be facing these many situations. So that only for that reason they have introduced this partial correlation. Okay, options there is not required. If you want to find out means and standard deviation, that is up to you, or there is no need of this one, then no need of clicking on this. Okay, I'm clicking this one, and two-tailed, you need to always go for two-tailed one only for any of the significance tests. Okay, so and display, actually if you know very clearly about it will be going for one direction, then you can go for one tail, but most of the times click on two-tailed and display actual significant levels. Okay, so that also possible thing here that you can do. Okay, I'll be stopping now, and means I need to share the screen again. The output one. Okay, now what happens? Okay, the screen is comes here. X3 is a control variable, and we are finding out the relationship between x1 and x2. Okay, are you clear about this?
Yes, sir.
Okay, so what is the correlation here? The value here.
0.533.
Okay, that means what it means. What it means. We also studied here the table. Okay, I have sent you the information about you. Okay, if it is 0.5 to 0.7, then it is a strong positive correlation among the 2 variables when the controlling over some other variable is there. Okay, now what I do is I'll compute the other variables also, and then I'll come to you.
Sir, at last, can you just tell us how to plot the graph of this partial correlation?
Partial correlation, we need to get only a scatter plot will give you the 2 variables only. Okay, so only it will be possible for this one. Okay, I'll be telling you why means when you are plotting graph. Okay, so only 2 variables can be possible with the scatter plot. Okay, there will be no controlling variable, but when you are dealing with this, so in any of the textbook also it will not displayed. I'll be giving you more information on this. Okay, when it comes for maybe I'll see that any graphical representation is there for partial correlation, then I'll check about it. Okay, x3, this screen is visible to you?
Yes, sir.
Okay, x1, x3, the controlling now I am giving here, and other thing also I am just opening that partial, and what actually I can do is here. Okay, this is the thing. And, x2 is came here, x1, x2, and controlling here x3. No. I'm making mistake here. Are you able to see the screen?
Yes, sir.
Okay. So this is here x2, x3, and this is 1. Okay, so now I'm going to the output window of this, and I'm sharing that. Okay, you see here now controlling variable. First we made control variable as x3. So we found the correlation among the x1 and x2, and the next one control variable is x2, and correlation we find out for the x1 and x3, and here controlling variable is x1, and we found the correlation among these two variables. Okay, now what is the 0.335 means?
Weak correlation, weak positive correlation.
Yes. Okay, and now this one 458.
It is also weak positive correlation.
Okay, good, very good. Okay, so up to now I'll stop here for today. Okay, tomorrow we will be covering remaining portion. Okay, thank you. If you have any doubt, you can ask me, so I'll be able to answer your questions. The plotting part I'll be telling you by means this will not come here, but I'll be telling you whether if it is possible. I'll be explaining you that also.
Okay, sir. Thank you.
Okay.
Thank you, sir.
Okay. Thank you. If you have any doubt, you can ask me at any time. And now also it is doubt session. You can also ask now. Okay. Thank you for today. I'll tell to the host to close this one.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.